Hello all, let us talk about impedance discontinuity. So, what do you mean by this word impedance discontinuity? When there is a driver which is driving a signal, okay, and let us assume there is a receiver which is receiving the signal. This is D and this is R. This is a signal path between the driver and the receiver, basically a routing between the driver and receiver on a PCB, right? So whenever whenever a source sends a signal to the receiver, basically the zeros and ones, right? If this signal sees different impedances along its path between the driver and the receiver, then such a condition is impedance discontinuity, where the signal might have reflections because of this discontinuity and it gets distorted. So one of the common problem that happens with impedance discontinuity is, let us assume there is a high signal. So this actually will have overshoot and undershoot, and uh, this causes issues, and also it can actually cause this kind of variations which is called ringing. Okay, so the distortion is so bad sometimes that the data gets corrupted. So now, what are the common causes of impedance discontinuity? Let us assume this is a PCB on which we have a driver and a receiver, and this there will be other components as well, right? And if a signal is input and if there is a via on this particular signal in the PCB, and the signal is routed in the inner layer and then connected this way. Let us assume it is connected this way. Okay, so this via actually introduces impedance variation. Via can be modeled basically with a inductance and capacitance, which are the elements which cause impedance variation, right? So we will talk about vias later. So vias are one of the important elements in a PCB which cause impedance discontinuity. And then let us assume there is a trace like this, and then we have a pull down resistor, okay, which is mounted towards the receiver end, and we made this pull down resistor DNP. So that means it's not populated. So this, when it is not populated, there will be a line that will be coming in parallel to this, which basically can be a source of impedance discontinuity if this line is longer than lambda by 4. Okay, so we know the frequency, we can calculate the lambda, and we can come up with the lambda by 4 value. Now one of the important point in high-speed designs is there should be a continuous return path underneath this main transmission line. Now, let us assume this is a driver, this is a receiver, and then we have a signal, and let us assume this is a return path underneath. So you can imagine if this is a top layer, you can imagine as the second layer as a continuous ground which provides reference. Now let us assume there is a cut here. Okay, so when the return signal comes this way, it tries to take a longer route and then passes back to the driver. So this signal is actually unintentionally traveling across the board, which might cause the issues that we are seeing due to discontinuity. That is one of the important parameter which need to be considered. So these are some of the parameters, and Another important parameter is we will have terminations that will be done in high-speed designs. You can look at our videos in our channel to understand the terminations. So, and there are many resources available over the internet. Like we will have source termination, which will be done near the driver, and there'll be a parallel termination, which will be done at the receiver side. So, if these resistors are used without a careful consideration of how the driver impedance is and then the line impedance is. This might cause unnecessary impedance discontinuity and reflections. Very important points, right? And when there are board to board connections, like let us assume there is a board here, okay, and then there is a connector at the edge, let us assume, and we have to connect another board. Now in this case, the signal will be coming to the connector, ground will be coming to the connector, and if the termination doesn't happen properly on this board, or if we are operating this board under open condition and trying to probe something here, this also might cause impedance discontinuity, which causes signal degradation. So, to summarize some of the points, ensure that there are no bias. If bias are required, use bias which are basically micro wires rather than a full through hole wire, so that you can eliminate some of the discontinuities. And if you have to use a full wire, you can use a costly back drilling kind of technique where some of the wire is cut off from the bottom, which is another way of reducing the impedance discontinuity. And if you are using a resistor, ensure that this resistor is placed as close as possible to the transmission line with the shortest number. In case if the resistor has to be the step cannot be eliminated. If the resistor has to be DNP, so the step will be as less as possible, which is helpful to eliminate any discontinuities. And as we talked here, use proper terminations. By using the simulations such that we have a very good termination happening without any discontinuities. Also ensure that when you are connecting, you connect starting from the driver to the receiver, and you eliminate any unnecessary deviations from the signal, like having another trace, which is like a star kind of routing, right? Or basically multi branches. So these kind of scenarios try to avoid. This is one more thing which need to be avoided to eliminate unnecessary reflections on the board. These are some of the things which cause impedance discontinuity, and some of the cares that need to be taken to eliminate impedance discontinuity. Please post if you have any questions. Please post your observations on this topic. Thank you.